You're standing in a forest and you are extremely hungry. It's 40,000 years ago, and there is no such thing as a label. In front of you is a bush covered in small, glossy red berries. They look perfect. They smell like nothing. They could be dinner. They could also shut your kidneys down before the sun comes up. There's no doctor here, no poison control, no second opinion. And here's the strange part. You already know what to do. Not because you're clever, but because somebody solved this long before you. Nobody in your group is going to eat that bush today. And that decision was made thousands of years before you were born. So how did ancient humans know which food wouldn't kill them? Seriously, think about it for a second, because the odds are terrible. There are roughly 400,000 known plant species on Earth. Only a few thousand of them have ever been eaten regularly. Most plants are not food. Most plants are chemistry that wants to be left alone. A plant can't run away, so it fights with poison instead. Alkaloids, tannins, cyanide compounds, oxalates, a whole pharmacy of refusal. You'd think early humans would have died constantly, in enormous numbers. One bad root, one wrong mushroom, one confident guess, and you're gone. But they didn't die out. They spread across every continent on the planet. They ate acorns, roots, seeds, fungi, and things you'd never touch. Somehow they got it right often enough to keep the species going. And they did it without writing, without chemistry, without a single test tube. Here's the thing nobody tells you about ancient food safety. It was never one brave person tasting things and hoping. It's not one thing. It's never one thing. There are layers here. Your tongue is one layer. Your memory is another. Your grandmother is a third. And the deepest layer starts before you can even open your eyes. 7 layers, easy to strange, and the last one is unsettling. Let's go. Start with the layer you're carrying around right now. Open your mouth and you're holding a chemical detection system. Humans have about 25 working bitter taste receptors, called tasters. 25. That's a lot of hardware for one unpleasant sensation. Sweet taste runs on essentially one receptor type. Bitter gets 25. That imbalance is a clue about what your ancestors were worried about. Bitter isn't a flavor. Bitter is a warning light on a dashboard. It exists to tell you that something in your mouth is chemically hostile. One of those receptors, TAS2R16, is almost comically specific. It detects a group of compounds called beta-glucopyranosides. That name means nothing to you, so here's what matters. Those compounds release cyanide when your gut breaks them down. And they're produced by more than 2,500 species of plants and insects. 2,500. That's not a coincidence. That's a defense contract. Your ancestors were being chemically attacked often enough to evolve a dedicated sensor. Think about that for a second, because it reframes the whole question. You don't have to learn that cyanide is bad. You're born knowing. A baby who has never eaten anything will gag at bitter. The reaction happens before any thought is involved at all. And it's not just a yes or no switch, it's a dial. Mildly bitter and you slow down. Violently bitter and you spit. That dial let ancient humans sample carefully instead of committing. Take a tiny piece, hold it on the tongue, wait. If it burns or bites or turns metallic, it leaves your mouth. That's not superstition. That's a receptor array doing quality control. Now, the tongue is a good system, but it's a slow motion system. Plenty of poisons taste fine, and we'll come back to that. So a second layer had to exist, and it's much darker. Here's what nobody tells you about throwing up. It's a filing system. In 1955, a psychologist named John Garcia ran a famous experiment. He gave rats a new flavor, sweet saccharin water they'd never tasted. Then, separately, he made them feel sick afterwards. One pairing, that's it. One taste, one bout of nausea. The rats refused that flavor for the rest of their lives. 30 days later, the aversion was still sitting there, fully intact. That is not normal learning. Normal learning needs repetition. You don't learn a phone number after hearing it once, but you learn a poisonous food after one experience, permanently. Garcia found something even stranger about the timing involved. The sickness could arrive more than an hour after the meal. The brain still reached back and connected it to the taste. An hour is an enormous gap for a memory link. But that gap is exactly how long real poisoning takes to start. Your brain evolved a delay window that matches plant toxins. And it's selective in a way that's almost eerie to read about. Garcia's later work showed sounds and lights wouldn't stick the same way. Pear sickness with a noise, and the rats mostly shrugged. Pear sickness with a taste, and it welded itself in place. Your brain has decided that illness is a food problem by default. You have almost certainly experienced this yourself at some point. One bad meal, and years later you still can't face that dish. You know intellectually it was probably a virus, not the food. Doesn't matter. Your stomach filed it and closed the case. For an ancient human, that bug was survival equipment. One survivable dose of something wrong, and you never repeat it. But notice the ugly part hiding inside that sentence. Somebody still had to get sick for the lesson to exist, which is why the third layer matters more than the first two. Here's the thing, nobody tells you about the brave caveman story. You've probably heard the version where somebody volunteers to taste things. A hero steps forward, eats the mystery root, and the tribe watches. It's a great image, and it's almost entirely wrong. Nobody in a small group can afford to lose an adult. In a band of 30 people, every single body is essential. You don't run poison experiments on your own hunters for fun. What actually happened is less dramatic and far more powerful. You watched. That's it. You watched everyone else's mouth constantly. Humans are almost unreasonably good at copying what others eat. A child sees an adult chew something and files it as food. A child sees an adult spit something out and files it as danger. No explanation needed, no chemistry needed, just one observed decision. Multiply that by every meal, every person, every day, for generations. The group becomes a database, and eating is how you query it. Elders were the most valuable part of that entire system. An old woman in a foraging band was a living index. She'd seen 40 summers of which plants' fruit when and where. She'd watched people get sick and remembered exactly what they ate. She knew that this root is fine in spring and vicious in autumn. That's not folklore. That's decades of observational data with legs. And here's a detail that makes the whole system click into place. Human children come with a built-in setting that looks like a bug. Food neophobia, the flat refusal to eat anything unfamiliar. It appears in the second year of life, right on schedule. And it peaks between roughly 2 and 6 years old, which is exactly when a small human learns to walk away. A toddler who eats everything in a forest doesn't become an adult. So evolution installed a phase where new food is presumed guilty. Your picky 4-year-old is not being difficult. They're running old software. They will eat what they've seen you eat and nothing else. That's not stubbornness. That's the safest possible strategy for a small body. But watching and copying only tells you what's already known. It doesn't explain the strangest part of ancient eating at all. Because here's where the story stops being about avoiding poison. A huge amount of what ancient humans ate was genuinely toxic. Not mildly unpleasant, actually poisonous in the state you'd find it. They ate it anyway, they just took the poison out first. In 2022, archaeologists published something remarkable from Shanidar Cave. That's a cave in the mountains of Iraqi Kurdistan. Dr. Taryn Kabukchu of the University of Liverpool led the study. In the journal Antiquity, her team described charred lumps of food. Burnt scraps, basically, left in the ash of ancient fires. The Neanderthal layers at Shanidar date to around 70,000 years ago. 70,000. Take a second with that number. And those scraps were not raw seeds thrown on a fire. They were bitter vetch, grass pea, and wild pea, deliberately processed. The seeds had been soaked, then leached, then pounded before cooking. Those pulses are bitter and mildly toxic if you just eat them. Soaking and pounding pulls the bitter compounds out into the water. So this is a recipe. 70,000 years ago, a recipe. And they had no pots, which makes it stranger still. The researchers think they soaked seeds inside a fold of animal skin, a hide, some water, and a multi-step process with a purpose. There was also wild mustard and terebinth mixed into the food, which means somebody was seasoning it 70,000 years ago. That is not survival eating. That's cuisine with a safety protocol. And the same trick shows up all over the world independently. Take acorns, which are everywhere and packed with calories. They're also loaded with tannins, bitter and harmful in quantity. Indigenous Californian peoples solved this with water and patience. Crushed acorn meal went into a sand basin or a woven basket. Then water, poured through again and again, sometimes over several days. The tannins washed downstream, What remained was flour, rich in fat and protein. For many California peoples, acorns became about half the diet. Half, from a nut that hurts you if you eat it raw. In the Andes, people found an even stranger solution. Some wild potato varieties are bitter and full of alkaloids, so people in Peru and Bolivia mixed clay with water into a slurry. Then they dipped the potato into the clay before eating it. That sounds like desperation. It's actually applied chemistry. Clay is made of microscopic charged mineral sheets with enormous surface area. The negatively charged clay grabs the positively charged toxins and holds them. The poison passes straight through you, stuck to the dirt. And that's not a metaphor, that's adsorption, the same principle in medicine today. People still do this in the Andes. It works. So the answer isn't just knowing what's safe, it's making things safe. Which raises a question that's genuinely hard to answer. How do you invent a 5-step process where no single step helps? Consider manioc, also called cassava, in the Colombian Amazon. Bitter varieties of manioc contain compounds that release cyanide. Eat it the obvious way, and you get chronic poisoning. Not dramatic collapse, slow damage, nerve problems, paralysis, over years. The Tucanoan people process it across multiple days and multiple steps. Scrape the root, grate it, wash it to separate fiber, starch, and liquid. Boil the liquid into a drink. Leave the solids for 2 more days. Then, finally, bake it. Only now is it actually food. Anthropologist Joseph Henrich wrote about this in 2016. He points out something that should genuinely bother you. If you skip a step, you feel completely fine that day. The damage from shortcuts takes years to show up in your body. So there is no feedback loop. Nobody can test the recipe. And when researchers asked people why each step mattered, they often couldn't say. They weren't hiding knowledge. The reasons had simply never been visible. Henrich calls this causal opacity, and it's the whole secret. The process works. Nobody who performs it fully understands why. It was never designed by a person. It accumulated. Thousands of small variations across generations, filtered by who stayed healthy. Families who did the long version had fewer sick children. Their neighbors copied them without knowing which step was doing the work. Over centuries, the useless steps drop away, and the useful ones stay. What's left looks like a ritual and functions like a laboratory protocol. This is the part people miss about ancient food knowledge. It isn't intelligence, it's inheritance, tested by a very unforgiving referee. And the proof of that shows up when the recipe travels. Cassava didn't stay in the Amazon, where it was first domesticated. In the 16th century, it crossed the Atlantic to Africa. The plant traveled easily. It grows in poor soil and resists drought. But the plant arrived without the instruction manual attached. The Amazonian processing knowledge did not come along in the boat. So people had to rebuild the whole thing from scratch. And they did. That's the part I find quietly astonishing. Across West and Central Africa, new methods appeared over generations. Grating, dewatering, fermenting, and roasting became a process called making gari. Those combined steps remove somewhere between 80 and 95% of the cyanide. Sun drying turned out to work better than fast oven drying. Longer contact time lets the plant's own enzyme break down its own toxin. Nobody knew the word enzyme. The method still found the enzyme. Think about what that actually demonstrates about human beings. Given a poisonous plant and enough generations, we will disarm it. Not by understanding it, but by copying whoever survived it. The knowledge isn't in anyone's head, it's in the population. You can lose every individual and keep the recipe alive. You can lose the recipe and rebuild it within a few centuries. That's the real answer to how ancient humans knew what was safe. They didn't know. Their culture knew, and they trusted it. Which brings us to the weirdest use of poison in the whole story. Here's what nobody tells you about that bitter warning system. Sometimes ancient humans tasted the warning and ate it deliberately. In 2012, a team led by Karen Hardy published a strange finding. They studied hardened plaque on Neanderthal teeth from El Cedron in northern Spain, dental calculus traps, microscopic chemical traces of what a mouth processed. And inside it, they found yarrow and chamomile. Both plants are bitter. Both have almost no nutritional value at all. You don't eat yarrow because you're hungry. It's not food. Both are, however, well-known medicinal plants used for thousands of years. Here's the detail that makes this genuinely hard to explain away. Those Neanderthals carried the bitter taste gene TAS2R38, the researchers found, meaning they could taste exactly how unpleasant those plants were. They tasted the alarm, they swallowed anyway, on purpose. That's a completely different relationship with plant chemistry. Not just avoiding poison, and not just removing poison from food. Using a mild poison, in a small dose, to fix something. That's the beginning of pharmacology, in a cave, before our species dominated. The line between poison and medicine is only ever the dose. Ancient humans figured that out with no idea why it worked. And you're still doing it. Coffee is a plant insecticide. Chili heat is a chemical designed to punish mammals for eating it. You pay money for both, and you call it a treat. The alarm system is still there. You've just learned to enjoy it. Now let's be honest about the size of the hole in all this. Everything I've described is a very good system with a fatal blind spot. Because the whole thing assumes that dangerous food announces itself. Bitter warns you, sickness teaches you, elders remember for you. And then there's the death cap mushroom, Amanita phalloides. It does not taste bitter, it does not taste wrong. Survivors have described it as one of the best mushrooms they'd eaten. So the tongue layer fails completely. No warning light at all. Then symptoms don't start for 6 to 12 hours, sometimes up to 24. By then, the meal is long over and it feels like a stomach bug. So the aversion layer fails too. The link is too far away. And its toxins survive boiling, frying, drying, every cooking method there is. So the processing layer fails. You cannot leach a death cap safe. 3 of the 4 defenses defeated by one organism, which leaves only the 4th, somebody older telling you not to. That's why fungus knowledge was passed down with such fierce precision. Not general rules, but specific ones about specific local species. People absolutely died learning this. That part of the story is true. The myth isn't that people died. The myth is that they died randomly. There's one last layer I saved for the end, and it's the wildest. Because we've talked about tongues, memory, elders, recipes, and culture, all of that requires you to already be alive and paying attention. In 2022, researchers at Durham University published something extraordinary. The study appeared in the journal Psychological Science. Beza Ustun and Professor Nadja Riceland led the work. They ran 4-dimensional ultrasound scans on 100 pregnant women. 20 minutes before each scan, the mother swallowed a capsule. Inside was roughly 400 milligrams of powder, either carrot or kale. Then they watched the unborn baby's face on the scan. The fetuses given carrot made more of what researchers call a laughter face. The fetuses given kale made more of a cry face instead. Kale is bitter, carrot is sweet. The faces matched perfectly. A small dose of flavor was enough to get a reaction. Think about what that means about when food learning starts. Flavor compounds from the mother's meal reach the amniotic fluid. The fetus swallows that fluid and tastes what she has been eating. So, before you had a name, you were being briefed. Every meal your mother ate was a message about what's available and safe. Sweet and rich meant this is worth eating. Bitter meant be careful. You arrived preloaded with a summary of your local food supply. And that chain has never once been broken in your entire ancestry. Every human who ever lived was taught this way before birth. You didn't learn which foods were safe. You were told before you had ears. 100,000 years of chemical messages, mother to child, unbroken. That's not folklore or instinct. That's a courier system made of fluid. So come back to the forest and the bush and the red berries. You're standing there hungry and you don't eat them. That single decision is not really yours when you look closely. It's 25 receptors, shaped by plants that tried to kill your ancestors. It's every relative who got sick and lived to warn somebody. It's an old woman pointing at a plant 400 generations ago. It's a soaked seed in a fold of hide in Shanidar Cave. It's a flavor you tasted before you had a face to taste it with. You walk through a supermarket and it feels like nothing at all. But every safe thing on those shelves was once an open question. Somebody answered it, slowly, and then handed you the answer for free. You are the descendant of everyone who guessed carefully enough.